If you are watching this video, this means you read the title, and yes, I will prove you why the tesseract, or also called the four-dimensional cube, doesn't look like that. For those who don't know what a dimension is, I have said, a dimension is the maximum number of independent directions within a mathematical space. You can also call it just a way of representing objects. As we all know, geometric figures have many forms like triangles, rectangles, and squares. But today we are going to focus on the square. So let's break this down, but before I would like to ask you a question. Did you ever heard of the zeroth dimension? The zeroth dimension is simple, a point. It has a quantity but no specific direction, and it's the lowest among all dimensions. But if you take 2 points and bring them together, it will form a line, which is the first dimension. If you take 4 lines, it will make a square, which is the second dimension. If you take 6 squares, it will form a cube, which is the third dimension. For now, let's stop here. For those who are studying trigonometry or don't know what a vertical, an edge, and a phase is, then these are the similarities or equivalents of the other. This is when things start getting interesting. We all know that we can form the next dimension from the previous one, but were you aware about the fact that we can resolve all this into one equation? I decided to call it equation star. And it's what you are seeing up there. With this equation, you can find the next one. If you try right now, you will see that it works for the first, second, and third dimension. Crazy, right? But this equation has one limitation. It can only be used in the cases of a square. It won't work for other figures like a rectangle, a triangle, a prism, and so on. What we can observe 2 things from this equation: dimensional relationships and scaling factor. Dimensional relationships simply mean that every dimension is related to the other, and scaling factors means that the number of elements increases as we move from a lower dimension to a higher. In most videos you have seen that a tesseract is formed from 2 cubes. But according to the above equation, you will instead need 8 cubes to form a perfect tesseract. But this equation in itself has some limitations, or you can also call it problems. But that doesn't mean my equation is garbage or crazy conspiracy theories. Because if that was the case, I wouldn't reveal them to you. To make you see the problem with my equation easier, I will show you an example. We have earlier talked about verticals, edges, and faces. Now, a cube has 8 verticals, 12 edges, and 6 faces. According to my equation, a cube should normally have 48 verticals, 24 edges, and 6 faces. The reason for this is when moving from a smaller dimension to a higher, each component is shared between each other. For example, one line has 2 points, but when you put 4 lines together, each line shares one of its points with one another, like in a chemical reaction between hydrogen and oxygen to form water. Each hydrogen shares one of its electrons with oxygen to make just one compound. I hope the example named above was good enough. So just use my equation to determine the number elements you will need to form the higher dimension. If you have any idea, question, or want to talk about another topic, don't forget to share it in the comments. They are always welcomed. I will be reading them. I hope you guys loved my video. If you did, like and subscribe, and see you next time.